All right, so factoring. First thing we do with this is we make sure it's in standard form. That's true. Then we're going to take the first term and put it in the first box, last term in the last box. Okay, you should be able at this point to do that. When you see factor, draw the box, put the first in the first box, last in the last box. Now, we're going to draw our big X. A times C is negative 18 and B is negative 7. What two terms can I multiply together to give me negative 18, but add together to get me negative 7? Negative 9 and 2. Why wouldn't it be negative 2 and 9? Can anybody tell me? Okay. Right. So if we added it together, that would be wrong, right? But this is correct. Okay, so we've got negative 9x and 2x. Okay, hey, what's up? Ready? So what times what would give me x squared? X times x, right? What times x would give me 2x? 2. What times x would give me negative 9x? Okay, so factored form would be x minus 9 and x plus 2. This is like the one that was on your mastery check. So we're going to take out the greatest common factor. And the reason why we're going to take out the greatest common factor is there's no C term, right? There's no like plus constant. So 4 and 100, what can I take out from both? 2. Is there a bigger factor? Okay, 4, because is 100 divided by 4 something? Yeah, what is that? 25. 25. Okay, so 4 we could take out. What else can we take out from these two things? Well, they both have an x. So what's 4x squared divided by 4x? What does that give you? X. What's negative 100x divided by 4x? Negative 25. Okay, so what you're going to do first is you move that 2 to the other side. We just talked about this. And so now this has it in standard form. Okay, draw your box. First term goes in the first box. Last term goes in the last box. Now you're going to set up your big X. A times C is 24 and B is negative 10. What two numbers can I multiply together to give me 24, add together to get me negative 10? Good. Negative 6 and negative 4. Are there any questions up to this point? Everybody's okay? You can get here. Okay. So now we're going to say, what times what gives me n squared? N and n. What times n will give me negative 4n? And what times n would give me negative 6n? And we always check with this last box, make sure it works. Now, they said to solve by factoring. So that means that my factored form is going to look like this. But if I want to solve, I got to take each one of these, set them equal to 0, and then solve. So that will give me n equals 4 and n equals 6. 7. Good work. Okay, let me use Benjamin. Okay, look at his work. First of all, look at that handwriting with a mouse pad. Great. Okay, do you agree? Do you agree? How are they similar? How are they different? How are these answers similar and different? Look at them. Okay. Well, this one's repeating, right? And these have two different ones, right? Okay. Go ahead and go to slide 2. So x plus 4 squared and x squared plus 8x plus 16 are perfect squares. These are not. What do you think makes a perfect square? Go ahead and type that out. All right, so y'all said a perfect square is equal on both sides. Boom. Nicholas gave an example. So he said x plus 2 times x plus 2. Okay. All right, so it's going to have that same length on both sides. Okay, so that's going to give me x plus 4 on this side, x plus 4 on this side. if they have different lengths, what shape does that make? What shape is this guy? A rectangle. And that we learned back in like elementary school that rectangles are not squares, right? We learned that? Yes. Okay, cool. All right. Go ahead and go to slide 3. Tell me, is this a perfect square? How do you know? Take a moment. How do you know? So why is it yes? Because what? The sides are the same. Okay. Another thing that you could also notice is, do you remember back when we did radicals? And I was like, here are all the perfect squares. It would be helpful if you have them memorized up to 12. Look at what the last number is. 144. That's a perfect square. Okay. All right, go ahead and take a moment. Sort your cards on slide 4. Check your work. So if you got orange in here, wrong. Okay, these are the perfect squares. Okay. The reason why is because if you have the same thing squared, that's a perfect square. If this last number is a perfect square, normally it's going to be a perfect square. Normally. However, notice how this and this are very similar, but what's different about them? That one's negative. Okay. Remember, this number is going to impact the next one. So we would have to have like a negative and then like a positive if it was written out in standard form. Okay. These are all perfect squares. Okay. So good job. Let's go ahead and go to the next one. Yeah. So how did you decide whether this expression was a perfect square? Because this one was a little tricky. How did you decide? Take a moment, your time. In order to figure this one out, what would you have done? Do you notice anything? If I wrote this, I know this is a perfect square because this is a perfect square. What's the square root of 144? 12. Take 12, multiply it by 2. Isn't that what this number is? Okay, so if we're here, what we can do is we can take 5 divided by 2. Tell me what that is. 2.5. And then take 2.5 and then square it. Go ahead. It's 6.25, right? That's why this is a perfect square. Oh, fun fact. All right, so go ahead and take a moment. See if you can answer slide 6. This perfect square was written in standard and factored form. However, some of the numbers are smudged. Is there enough information to determine the smudged numbers? Okay, so if I took this.
You think that Simon had any right things?
No.
So how do you make anything?
Right.
So then I was in this news. He has been not sure about
Okay, so when you're building these algebra tiles, you want to create a square. If I were to set it up like this, how many little tiles could I fit inside of here roughly? Can you think about it? Not 6. It's 9, right? What's 3 squared? Isn't there 3 right here? Yeah, there's 3 right here. And then this would be 9. Does that make sense? This is very similar to our algebra model. Okay. So if we're here, what's 3 times 3? 9. That's why it's in that bottom right. Okay, can you try challenge number 7? Yeah. Okay, so C is smudged. How do we figure out what that number is going to be? We just talked about it, right? We said take the B term, divide it by 2. So take 22, divided by 2. What do you get? 11. Now take 11, let's square it. What's 11 squared? Okay, so this is going to be 121. That's 121. Go ahead and take a moment and write that out. Write what we did out in Word. On slide 9, what you're going to do is you're trying to do these challenges. You're going to do 3. So you'll get 3 little gold stars. In order to solve this, you're going to take your b term, divide it by 2, and square it. So what's negative 10 divided by 2 on this one? Negative 5. Negative 5 squared is positive 25. Remember, a negative times a negative equals a positive. Okay, so I would type 25, and then I can hit try it. It would tell me if it's right or wrong. You're going to do this 3 times through. On slide number 11, tell me, how do you determine whether an expression is a perfect square? How do you determine if the expression is a perfect square? Once you finish that, go ahead and go to slide 12. Okay, so on here, you should have gotten, I only have 6 people on here. Okay, so you should have gotten this. So how you do this, my turn. Okay, you're going to take b, divide it by 2, and then square it. So what's 8 divided by 2? 4, and then 4 squared is 16. For this one, it's kind of like you work your way backwards. So what's the square root of 25? 5, and then multiply that times 2. So that's where we got 10x. If we take negative 20 and divide it by 2, what are we going to get? 10, and 10 squared is, boom. Okay? Questions? B divided by 2, and then square it. The first one, same thing. Yeah. Over this. All right, so on 9b, what's happening is we move the c term to the other side. That's the first thing we do. Okay, so we're going to add 63 to the other side. Does anybody have any questions about that? Okay, the reason why is because, watch. Can you think of 2 numbers that multiply together to give you negative 63 and add together to get you 2? Not 6 and 7. You could do 6 and 9. Now, let's say, for instance, it didn't work out well. Okay, let's say like you couldn't figure out those factors. Then you would do completing the square. Okay. However, probably would factor on this one. Okay, now what you're going to do is you're going to take your b term, divide it by 2, square it, and add to both sides. So what's your b term? 2. 2 divided by 2 is, and 1 squared is 1. Okay, so we're going to add it to both sides. Does everybody see where that came from? Okay. Now we're going to factor. So looking over here, over there in the green cup. So once we get here, we're going to factor. So you could do the a times c, so that would be 1, and b is 2. What 2 numbers will make that happen? 1 and 1. So this could be written out as x plus 1 squared. What's 63 plus 1? 5. So what's 63 plus 1? 64. 64. So now we're going to take the square root of both sides, and then we're going to solve. Okay? So when we take the square root of both sides, that's going to give me x plus 1 equals positive and negative 8. So if we move that 1 to the other side, that's going to give me x equals negative 1 plus or minus 8, which is 7 or negative 9. I'll be honest, this process is not your go-to how to solve, but you need to know the step because the question that you probably will be asked is an error analysis type question. Okay, so like somebody would show their work and then you would say what they did wrong. So you need to know these steps. Yeah, I know. So on slide number 2, what do you notice about each equation structure? Which equation could be solved by taking square root? Look at the ones that are on the board. Either A, B, or C. Which one could be solved by taking the square root? A. Okay, so A could be solved by taking the square root really easily. B, you would probably want to do completing the square or factoring. And C, again, you probably want to do completing the square or factoring. All right, go ahead and go to slide 3. Okay. On here, I need you to watch. Okay. You're going to move your C term to the other side. Notice how there's a number already over here. That's okay. We're going to subtract that 16. And that's going to give us -7. And then what's our next step? After we move our C term, what do we do next? Okay, so take B divided by 2 and then square it. What's -8 divided by 2? -4. -4 squared is +16 because negative times negative equals positive. Okay. Now, when we factor, we're going to get x minus 4 squared. What's -7 plus 16? -7 plus 16. 9. And then now we're going to take the square root. And so that's going to give me x minus 4 equals positive and -3. Move the 4 to the other side and solve. That's going to give me x equals 7 and x equals 1. 1 and 7. You try looking at slide number 4. See if you can answer that one. All right, let's talk about Devin and Tay. On the first one, what process did they use? So that would be factoring. That's what we learned last week. Okay. What about this one? What did they do? Well, they moved that 16 to the other side, and then they factored, and then took the square root. So this is called taking the square root. Also, kind of similar to completing the square. Good question. So you cannot factor on this one. You're going to have to complete the square. So what's going to happen is we're going to take B divided by 2 and square it and add it to both sides. So what's 17 divided by 2? And 7 squared is 49. 49 is the percent. No. Okay. On the other side, we're going to add 49 as well. Then we're going to factor. So that's going to give us x plus 7 squared equals 80. We're going to take the square root of both sides. This is going to give us x plus 7 equals positive and negative square root of 80. And then if we move 7 to the other side, our two x's are going to be -7 plus the square root of 80, -7 minus the square root of 80.